Howdy. We got a position function here, and there's a particle that moves on a straight line. Kind of goes back and forth like this. And it changes direction at time t. And if you think about it, if it's going to change directions, the time right when it changes directions, how fast is it going? Here it has a speed, it's changing directions, and it's going 0 before it turns and has a negative speed. So we need to find out when the velocity of this particle equals 0. So we have this question: when does v of t equal 0? Well, we can figure that out because we can find v of t. How do you get a velocity function given a position function? V of t, the velocity function, is the derivative of the position function. So we're going to take the derivative of e to the negative t cosine 5t. And we need to realize that what we have here is a product of two functions of t. So we're going to have to use the product rule, and we're also going to have to use the chain rule because on each one of them, because each one is a function of t. Now the product rule is the derivative of f over g is f prime times g plus f times g prime. So we get the velocity with respect to time is the derivative of f. So the derivative of e to the negative t is e to the negative t. Chain rule says we have to take the derivative of negative t. The derivative of negative t is just negative 1. So it's negative e to the negative t. That was our f prime. Now we multiply by g, which is cosine 5t plus fg prime. So plus f is e to the negative t, and then g prime. The derivative of cosine is negative sine. So negative sine of 5t times the derivative of 5t, so times 5. So we get negative e to the negative t cosine of 5t, and then we're going to multiply. We got times 5 and times a negative, so minus 5 e to the negative t sine 5t. And we can factor out an e to the negative t. Actually, we can factor out a negative e to the negative t. And we'll have cosine of 5t plus 5 sine 5t. And we want to know when does v of t equal 0. So we just need to set this equal to 0 and solve for t, or actually get it to look like one of these equations over here. And this is supposed to be an equal sign. Here, let me fix these real quick. Well, one thing we need to realize is that negative e to the negative t is never going to equal 0. So we're not going to get any solutions from this part, because negative e is just negative 2.71 something or other to some power. That's never going to equal 0. So we can divide both sides by e to t. This basically isn't going to give us any information. So the only time that this is going to equal 0 is when this factor equals 0. So we need to solve for this. Cosine of 5t plus 5 times the sine of 5t equals 0. And keep in mind, we need to do some algebra to figure out how to make this turn into one of these. So clearly, we're going to need to use some sort of trig identity here. I have cosine and sine. they can turn into tangent or cotangent. This one just has sine. This one just has cosine. Let's see if we can play around with this and get it to go into either tangent or cotangent form. So if I were to subtract cosine of 5t from both sides, I would get negative cosine of 5t equals 5 times the sine of 5t. Alright, so sine over cosine is tangent. So if I was to divide both sides by cosine of 5t, I would get negative 1 equals 5 sine 5t over cosine of 5t, but sine of 5t over cosine of 5t is just tangent of 5t. And then if I was to divide both sides by 5, these would cancel, and I would get negative 1/5 equals the tangent of 5t, which seems to match up pretty nicely with this guy right here. Now notice that if you were to take arctangent of both sides, do this in blue maybe, or no, I'm going to switch to lime green. If you take the arctangent of both sides, and you were to write it correctly, arctangent of negative 1/5 equals 5t. That looks really similar to this guy. So which one's the right answer? Well, this is going to happen. This, when velocity equals 0, we got a particle moving along a line, going back and forth, back and forth, back and forth. And it stops and changes directions a lot of times. Right? So there's going to be a lot of different t values. Arctangent has a limited range, so it's only going to return like one t value. So if we were to write this, we would limit ourselves to only one time that velocity equals 0. So technically it would satisfy both of these equations, but there's a lot of t values that aren't going to satisfy this equation, that will satisfy this equation, and that are times when the velocity equals 0. So we can't quite go this far, because that restricts our range, which cuts out a lot of our solutions. So this one is the correct answer. Now here's, we're going to continue with the same function, and now we're going to talk about when is the particle's speed at a relative maximum. So his speed is at a relative maximum when the velocity derivative is 0. So we need to take the derivative of the velocity here. So we know that v of t is, from the last page, we got negative e to the negative t times the cosine of 5t plus 5 times the sine of 5t. And if we're going to get the acceleration function, we need to take the derivative of the velocity function. So we need to take the derivative with respect to t of negative e to the negative t times cosine of 5t plus 5 sine 5t. All right, now again, we've got a product of two functions, so we're going to have to use the product rule. So f prime times g. So the derivative of negative e to the negative t is negative e to the negative t. But when we take the chain rule derivative, that's going to give us another negative. So that derivative is just going to become positive e to the negative t times cosine of 5t plus 5 sine 5t plus f times g prime. So negative e to the negative t times the derivative of this. Now this is just a sum, so I can just work through taking the derivative. Derivative of cosine of 5t is, derivative of cosine is negative sine, and then the chain rule is going to make us take the derivative of 5t. So this is going to be negative 5 times the sine of 5t. Then if we take the derivative here, the derivative of sine is cosine. So we're going to have cosine of 5t, but the chain rule is going to bring another 5 out, so 5 times 5 is 25. Now, if I factor out an e to the negative t and distribute this negative through, I'm going to get e to the negative t times cosine 5t plus 5 sine 5t, negative times negative is positive, plus 5 sine 5t minus 25 cosine 5t. And then I get some like terms in there. Cosine 5t and negative 25 cosine 5t. So e to the negative t times, here I got 5 sine of 5t plus 5 sine of 5t, so that's 10 sine of 5t, and then these like terms, cosine of 5t minus 25 cosine 5t is negative 24 cosine 5t. So we need to find out when the acceleration equals 0. E to the negative t is never going to equal 0, so this is going to only equal 0 when this factor equals 0. Now that'll only happen when 10 times the sine of 5t is equal to 24 cosine of 5t. So 10 times the sine of 5t has to equal 24 times the cosine of 5t. And let's see, sine over cosine is tangent. If I was to divide both sides by cosine of 5t and by 10 to cancel this off of here, these cosines would cancel and these 10s would cancel, and I would get sine over cosine is tangent, so tangent of 5t equals 24 divided by 10 is 2.4. And that is this guy right here. Well, that was fun. 2 problems. And it only took us like about 15 minutes. Hey, so that's calculus. Talk to you later.